So we're going to finish up the unit on rational expressions and equations by solving rational equations. And there is one more follow-up lesson to this. It's an extension and application of what we're about to learn today. But students start to get a little confused once we learn this part of the unit because everything feels very similar because of the notation of the expressions. So today we're going to be solving equations, and in order to do today's task, I actually need to go back and think about something we did a long time ago, like back in August. So this is an equation. It is a linear equation with rational coefficients. So it's kind of in the same spirit of what we're going to do today. But if you think about the technique we taught you back in August, we didn't want to work with the fractions. And because it was an equation, as long as we did the same thing to every single term in the equation, you could do whatever you wanted. So we looked at our denominators, which are 3 and 4 and 6. And we came up with a least common multiple for 3, 4, and 6. And technically, we could have come up with any common multiple. It just had to be a number that was large enough to be a multiple of 3 and 4 and 6. So we think 6 would be big enough because the 4 wouldn't divide into 6 evenly, so we had to go bigger. So we went with a 12. So if you throw a 12 in front of the equation, that inspired you to distribute. So the 12 was distributed to every term, whether it looked like a fraction or not. Whoops, I missed a term here, didn't I? This guy. And over here as well. So 12 times 1/3 x is going to reduce, and 12 times 1/4 is going to reduce, and 12 times x is just going to be 12x, and then 12 times 1/6 is going to reduce. So the beauty of what happened here is when we started with rational or fraction coefficients, we didn't end up with them anymore, because 12 times 1/3 becomes a 4x, plus 12 times 1/4 was a 3, 12x just stayed as 12x, and then 12 times 1/6 is minus 2. So then we ended up with a multi-step linear equation that we could solve really easily, and we didn't have to work with fractions anymore. So we would continue and solve, of course, but we're going to move on for the sake of time. What we're going to be doing today is solving rational equations that have not just singular, like rational coefficients, but the denominators are going to be the problem, right? They're going to be polynomials today, so not just like a 4, but an x plus 4, which makes things a little more difficult. If you think about how we found these common multiples and how we found common denominators in the last lesson, it's very much inspired by that thought process. So before we get to solving, let's talk about what we can't have as solutions. What we're going to determine now is what an excluded value is for an equation. So this is some vocab we need for today. So far LCM, or least common multiple, is one thing, and then excluded value is another. So these are all 3 separate equations. And my question to you is not necessarily can you solve it, but can you look ahead in the question and tell me what answers I can't get? So a fraction cannot have a divide by 0. You can't have like something and then divide it by a 0. So this cannot happen. So think about what would make that happen, because that would be my excluded value. That would be my problem. So what if x was negative 6? Wouldn't that be a problem? Because negative 6 plus 6 would be divided by 0. So x can't be negative 6. That's my excluded value. So here, if I think about this denominator and what would cause it to be 0, you could set up what we used to call an anti-equation. You could say x squared minus 36 cannot be 0. And then think about us solving this. We'd add 36 to both sides and then square root. So it works just like an equation. Just have a not equal to symbol. So x cannot equal plus n minus 6. So in that case, we had 2 excluded values. And then in this one, we have 2 separate denominators, x plus 9 and x minus 2. And both of them would have a cause for having a divide by 0 situation. So we have to tell our reader that the excluded values in this question are x cannot be negative 9 and x cannot be 2. So excluded values, the concept of excluded values, is just looking ahead in your problem and saying, okay, after I do all this work, I just have to remember that if these answers show up, which they do sometimes today, that we actually have to cross them off, and they're going to be called extraneous. All right, so before I get going on this question, I'm going to talk about what the excluded values are, just so I know. And if I look at my denominators, this denominator doesn't have a variable, so that's not a problem, but each of these denominators have variables. So if I think about x can't be 0 and 3x can't be 0, both of those denominators give me the same excluded value of x cannot be 0, because that would give me a divide by 0 situation. So after we solve this equation, I have to kind of go back and look at my answer and make sure that it's not 0. So just like with August problems, we're going to put big parentheses around the entire problem, the entire equation, I'm going to look at my denominators, and I'm going to come up with the least common multiple of my denominators. So very similar to finding a common denominator, because there we also look for a least common denominator. But this time, instead of building it up, I want to get rid of it. So our LCM for this problem, or LCD, some people call it least common denominator, I call it least common multiple. For the denominators are, we need a 3 and an x. So 3x, and you can say it's 3x over 1 if you'd like, is going to get distributed to every single term. And I'm going to write this one out the long way, and then after that I'm not going to write them out the long way anymore. So it's 3x over 1 times 7 over x minus 3x over 1 times the next term, which is 1 over 3x, equals 3x over 1 times 5/3. So each one of these multiplication problems are caused by us. We did them on purpose because now we're going to have some cancellation and we no longer are going to have to worry about denominators. For instance, look at this fraction right here. The x's would cancel, right? So you're gone, and you have 3 times 7, which is 21. Minus, in this next fraction, the 3 and the x would cancel. And you have 1 over 1, which is still a 1. A lot of kids tell me that's a 0, and that's not quite right. And then this last fraction, the 3's would cancel. And you have x times 5, better known as 5x. Now I have a very easy equation to solve. So I have 20 equals 5x, and then x equals 4. And the only last minute thing I have to check is that is 4 going to be an extraneous value because it was excluded at the beginning of the problem, and it's not 0, so that means this is a good answer. We're going to keep it. Alright, so that's the idea. Very, very similar to what we did in August, and also has a lot of commonalities with what we did in the last lesson. So here we have some factors. So of course we're going to think about factoring. X minus 2 is something I have to worry about. X plus 2 is a different thing I have to worry about. And then x squared minus 4, I think if we factored it, we're going to see that he's got 2 pieces, 2 factors, x plus 2 and x minus 2. So just like with least common denominators, when I'm coming up with the least common multiple, I want to come up with the least one because that's going to give me the least amount of work. And it's also going to help me avoid excluded values and extraneous answers that don't really work. Speaking of which, I should have come up with that. My excluded values, now that we're factored, x can't be positive 2 and x can't be negative 2 in any of the denominators. So x cannot be positive or negative 2. So just remember at the end of the problem, if I get either one of those answers, I'm going to have to cross them off. So my least common multiple for this problem, I'm going to need an x minus 2 as a factor. I'm also going to need an x plus 2. And that's going to knock out all of my terms, all my denominators. So we're going to multiply everything by x plus 2 times x minus 2, and you want to leave it in factored form over 1. So one more big distribution, and this is the last time, I think in the notes, well, maybe we'll see. I'm going to write this out the long way. So x plus 2 times x minus 2 over 1 is being multiplied by our first fraction, which is 3x over x minus 2. You know me, I like parentheses around my factors, so I'm going to keep those. And then x plus 2 times x minus 2 over 1 times the next fraction, which is 1 over x plus 2. Again, keeping parentheses around the factors, equals x plus 2 times x minus 2. Come on, pen, don't do that thing that you do when you stop working. Alright, times our last fraction, which is a negative 4 over x plus 2, x minus 2. I'm going to keep that factored form. Factored form is where it's at when you go to reduce all these. Alright, so let's look at each multiplication problem that we created because we're going to see some awesome cancellation. Alrighty, so first fraction. The x minus 2s are going to cancel. So we still have x plus 2 times 3x. We're going to have to distribute that. If you already did, that's fine. I'm just going to leave it alone for a moment. These are really easy to mess up on, so I'm going to go kind of slow. X plus 2s are going to cancel this time. So I have x minus 2 times 1, so just x minus 2. You can lose the parentheses because there's nothing multiplying by it. And then our last fraction here, the x plus 2 and the x minus 2 are both going to cancel, and you have negative 4 times 1, which is just a negative 4. All right. Yeesh, we got a quadratic, people. All right, 3x squared plus 6x plus x minus 2 equals 4. And because we have a quadratic, we have to collect all of our like terms to one side and set it equal to 0. We're probably going to factor this to find our answers. So 3x squared, adding these x's together, I get plus 7x. And then I would have subtracted this 4 over here, so minus 6. Good thing you guys are so wonderful at factoring. Here we go. 3x and x are going to be my initial terms for my factors. And then I have to have my last numbers multiplied to negative 6. I'm thinking 3 and 2, and I'm thinking putting a 3 here would be silly because I'd have a common factor, which I don't have. So let's put a 3 here and a 2 here. What if I made it a positive 9, though? Because it'd be positive 9 minus 2. That would give me the 7 in the middle. Okay. So solving each of these factors, set each of these factors equal to 0 and find the solutions. So this guy gives me 2/3 when I solve it. I'd add the 2 and divide by 3. And this guy gives me negative 3. So before I commit to these two answers, go back and remember that you have two excluded values. X can't be 2 or negative 2. And good news, we didn't get either of those answers. So both of our answers are going to work. They're both good. So as far as checking goes, that's all I do for checking. Is it an excluded value? If it's not, let's just keep it. Okay, that was probably the most challenging as far as like rigor of what I would test you on. Developing a quadratic through your math creates more work. Yes, that's a good time though, isn't it? All right, so this is still irrational. Let's start with the excluded values, just so I have this written down. The excluded values, whoops, for this problem, there's only one of them, and it's x can't be negative 3. Because that would be this guy equaling 0, or that one. So my LCM is actually pretty basic here. It's just a factor of x plus 3. So let's talk about what I could multiply this entire equation by. That's going to be the x plus 3. So here's what's going to happen on this next one. I'm going to show you how you can take a bit of a shortcut as far as like how to show work without writing everything out. Now, if you're not ready for that, then pause the video and please do what we did on the last couple of problems where you wrote this green LCM in front of each fraction. I'm going to anticipate the cancellation. That's what I'm going to do. So this first fraction, the x plus 3's are just going to cancel. I can see that very clearly. So we're just going to be left with the 2x. This next fraction, nothing cancels. So this negative 5 is still going to have to be multiplied by the x plus 3. And then in this final fraction, after the equal sign, the x plus 3's will end up canceling each other, and we're just going to have a 1 times a 1, so a 1. So that's how you can skip a little bit of work. It is tricky when you have more than one term in your LCM, so you have to be careful about that. And now we're going to solve. So I'm going to distribute carefully, because I know little mistakes are costly here, negative 5. And you end up with 2x minus 5x minus 15 equals 1. So that's negative 3x. I'm going to add this 15 over here. Equals 16. And x equals some gross fraction of negative 16/3, which is not negative 3, clearly, so I'm going to keep it. Good answer. Supposedly. I don't know. All right, this next one. Some kids say, hey, can I collect these 2 and the 12 together? Yeah, you could, but I'm not going to worry about it. Excluded values, let's talk about that. Since we have monomials, for some reason that really messes with kids. If I think about my monomial here and here, x can't be 0 and 3x can't be 0. But either way, if I solve this one, I end up with x not equaling 0. So that would be my excluded value. X can't be 0. Kind of boring, huh? So the LCM. This time I want to make sure I can knock out everything that shows up in the denominator. So at x is a part of 3x. Remember, those monomials can come out in pieces. So 3x is the LCM that we're going to be using. And I'm going to use that little shortcut again. I like that shortcut. So everything here is going to get multiplied by a 3x. Again, if you're not ready for this shortcut, please pause the video and show the distribution of 3x to every single fraction. So what's going to happen in this first fraction? The x's will cancel, but you still have 3 times 3. So that ends up being a 9. Plus 3x times 12, nothing cancels, so you just have 36x. Next fraction, nothing cancels, so you have a 6x, 3x times 2. And then in our last fraction, the 3 and the x will cancel. So you just have 4 times 1, which is a 4. And you guys could solve this one in your sleep. You're super good at solving equations. That would be kind of cool if you could solve these in your sleep. Catch up on your snoozes. All right, 30x equals, oh gosh, let's see, -5. Now this is where my dyslexia gets me in trouble because I start looking at these numbers and going, -6 is the answer, but we're dividing by 30, so it's actually a fraction. And you end up with x equals -1/6, which is not my excluded value of 0, so I'm going to keep that answer. So far, so good. All right. There's some exciting problems coming up. All right, let's jump ahead to number 7. Let's start by looking at these denominators and realizing that, while this one's fine, this denominator right here, this is factorable. X squared minus 1 is really x plus 1 times x minus 1. It's very important that you see the factors as separate pieces and separate numbers, because now I can tell two things, my excluded values, and I can also tell my LCM. The excluded values are that x cannot be positive or -1. So we have to keep that in mind. And then the LCM that I'm going to multiply everything by is both the x plus 1 and the x minus 1. So this time I'm going to actually show all the work on this one. This one can get a little confusing if you don't see where the work's coming from. So everybody's getting multiplied by x plus 1 times x minus 1. Here we go. All right. X plus 1 times x minus 1 over 1 is first being multiplied by 5x over x minus 1. Again, I like parentheses around my x minus 1s. Minus. And then this x minus 1 times x plus 1 is being multiplied by 2. So it doesn't matter what order you write this down in. I just need you to realize that there's no denominator, so there's no cancellation. That's going to be our problem right there. This is where the kids are going to mess up the problem, right here. In our last fraction, x plus 1 times x minus 1 is being multiplied by the fraction, no negative, 14 over x plus 1 times x minus 1. All right, each one of these fractions was caused by us. Now this one's not very exciting, I'm just going to leave it alone for a minute. And then here, the x minus 1s will cancel, and you're still going to have an x plus 1 quantity times 5x. So you do have to distribute that. I'm going to hold off on the actual distribution yet. Over here, lots of cancellation, that's good. X minus 1s and plus 1s cancel, and you get 14. But this middle part is the problem. So the -2 has to be multiplied by all of this, and you have to do this in 2 steps. So first thing I'm going to do is rewrite this as x squared minus 1, and then I'm going to bring the -2 down and distribute it. And since I already have more distribution to do, I'm just going to do it right here in this step. So when you have multiplication, like 2, 3, 4, 5 things that have to be multiplied together, you have to do it in stages. All right, now let's distribute. This becomes 5x squared. I should have warned you to write smaller on this one. Plus 5x. And then keep distributing the -2. X squared, careful here, this is plus 2, equals 14. And yay, we have a quadratic. So let's bring everything to one side so it says equals 0. I'm going to collect my quadratic terms first. This is a 3x squared plus 5x. And then I would have subtracted this 14 over. That's a 14 minus 12 equals 0. So again, you got good factoring skills. Let's use them. I know my first part of my terms, my factors are going to be 3x and 1x. Oh boy, 12 has a few options here. We've got 3 and 4 and 6 and 2. I think we're going to use 3 and 4. Now, it wouldn't be smart to use 3 here, because that would be a common factor, so let's put 3 here. And that'll give me a 9 and a 4. So if you made this a positive 9 and a negative 4, then my arches would add up to 5. Awesome. So, setting each of these equal to 0. This one is going to produce 4/3 if you solved it. And this one will produce -3. Then I go back and remember I have 2 excluded values, positive and -1. Neither one of these are positive or -1, so let's keep them both. Awesome. Alright. Yeah. It's a lot of work. Oh, that one looks fun. Let's do this one. And we have a couple more after that, and we're good to go. Alright, so this denominator is fine, this denominator is fine, but this last denominator, I think it's factorable. And don't think too hard about it, guys. This factors into these two factors, so they're not going to introduce like a gazillion terms into your problem. So you might notice that your factors of a polynomial show up somewhere else in another denominator, so that's good. Let's talk about our excluded values. X cannot be 2. And then if you solved this one, you'd subtract 2 and divide by 3. So the other thing that's a problem is negative 2/3. Alrighty, let's take a look at LCM. So I just need to worry about both my factors. X minus 2 needs to cancel, and 3x plus 2. This one I am totally going to take a shortcut because the writing would make you go crazy. So you have x, not that. You have x minus 2 times 3x plus 2 is getting multiplied to everybody. So in this first fraction, the x minus 2's will cancel, but you still have a 3x plus 2, and you still have to multiply it by a 2x. I should have written that in front, sorry. Minus this next fraction, the 3x plus 2's will cancel, but you still have, and this is a quantity, 4x plus 1, minus 1, geez, and it's still being multiplied by x minus 2. That did not cancel. And then in our last fraction, everything canceled, so you just have the 17x plus 4 with no multiplication. This one's going to be tricky, okay? So we need to distribute the 2x here. Hold off on the negative distribution. I'm going to need you to FOIL this one out. Oops, that's weird. So we have 6x squared plus 4x, leave a negative, and then leave a set of parentheses. And I'm going to clean this up as much as I can. I have 4x times x, so 4x squared. And then you have negative 8x plus negative 1x. So you have negative 9x in the middle. And then plus 2. If you didn't combine these middle terms and you left them separated, it's okay. Eventually you'll have to combine them. Now I'm going to distribute this negative into here. So remember, just like on that last problem we did, you have to do the distribution in stages. It's very tricky. Alright, so this is a minus 4x squared. It's now a plus 9x and a minus 2. Whew. Fun times, huh? And we have a quadratic. Alright, so quadratic terms, collect them together. Oh my gosh, golly, you have a lot of terms to do here. Linear terms, this guy's going to have to subtract over, huh? So let's bring this guy over as well. And then this 4 is going to have to be subtracted over. Alright, so living living life a little dangerously here, guys. I should have been more careful with my collecting of like terms. So this is 2x squared, and then 4x, 9x, that's 13x, but remember we're subtracting 17, so 13 minus 17 is negative 4x, negative 2 minus 4 is negative 6. So we do have a quadratic, but I have excellent news, I have a common 2, let's get rid of it. So, now my quadratic is x squared minus, not 4, Bruso, 2x minus 3. Oh, that's like a baby factoring question. X minus 3 times x plus 1 would be my factors. So that means my solutions are x equals 3 and x equals negative 1. And I go back up and make sure that neither one of them are my excluded values. They're not. So they're both going to be answers that I keep. You know, we never ran into one where we had an excluded value actually show up in the answer. So let me look here. Let me go back. I think I happen to skip over the 1. I think it's this one. Real quick, excluded value here is going to be x can't be negative 1. Maybe I'm wrong. I don't know. The LCM is clearly an x plus 1. So we're going to take a little shortcut here and do this one as quick as possible. I just want you to see what happens when the LCM or when the excluded value shows up as a solution. So first fraction, x plus 1's cancel, and you get 5x. Next fraction, nothing cancels, so it's 4 times x plus 1. We'll distribute in a moment, and then the x plus 1's cancel, so you get a minus 5. So, after a little distribution, and then collecting of our like terms, let's see, this becomes x equals, there we go, negative 1. But remember a while ago we were like, x can't be negative 1, it's excluded. So what happens then is you take all of your hard work, and you take the answer you got, you cross it off, and you write ext for this being an extraneous solution. And since we don't have any other solution that we came up with, and the one that we did find was crossed off, that means this problem has no solution. But don't fret. That is a solution in itself. The fact that there is no solution tells me a lot about that equation. So, silly on me to skip that question. That was important. In our notes, let's skip ahead to number 10 here. This might look familiar to you as a cross proportion. So you can continue to solve this like you would with cross multiplication or proportion solving, but really LCM is the same thing. So there's no factoring to do in our denominators, but the LCM that we're going to be using here are both the 2x plus 3 and the x minus 5. Which, when you do cross multiplication, this is exactly what you are doing. Just your little kid teacher didn't explain that to you. So this gets multiplied by this first fraction, and the 2x plus 3's will cancel. So the 2 is still getting multiplied by the x minus 5. And then in this fraction, the x minus 5's cancel. And that 2 is getting multiplied by the 2x plus 3. So, little distribution and solving. And this would be the exact same work you would have received or derived if you cross-multiplied like this, the butterfly thing that you guys call it. But this is truly what's happening. So 2x minus 10 equals 4x plus 6. And you know what? I should have started the problem with excluded values. There's 2 of them. X can't be 5 because of this denominator. And x can't be negative 3/2. So just keep that in mind. Alright, let's solve. I'm going to subtract 2x over here. So I'm going to subtract 6 over here. So we have negative 16 equals 2x, and x equals negative 8, which neither of those excluded values were negative 8, so that's a good answer. All right. I feel like we need to talk about this question. One more. This will be the last one we do. All right, so there's a couple of ways we could approach this. But I'm kind of looking ahead in this question, and I'm noticing that this denominator factors. You can take a 2 out, and then it becomes a 3x minus 1. Now, if you're a very sly creature, what you're going to notice is that these 3x minus 1s can technically cancel. There is nothing wrong with when you're solving an equation with getting rid of factors that you see are going to cancel, because what that's going to do for you is it's going to give you less work. So our problem is now all of a sudden 1 over 2 equals 2x plus 5 over 4x minus 13. So we don't have any cancellation on this fraction, but that's okay. What we've done now is we've eliminated an entire factor. Had you just cross-multiplied or just dealt with the 6x minus 2 as one of your factors, you would have had a whole lot of work come up. You would have had a really nasty quadratic to solve, and after you actually solved it, one of the answers you got would have been extraneous. It would have been 1/3, so you would have had to cross it off. So now that we've actually canceled the term at the beginning of the problem, I'm not going to have that extraneous solution show up. So, yay. I'm still going to cross-multiply though, or if you want to think of the LCM as 2 and a 4x minus 13. That's exactly what we're doing here. So distributing that to each fraction. This first fraction, the 2's cancel, and then 1 times 4x minus 13 is just 4x minus 13. And then this next fraction, the 4x minus 13 will cancel. So it's 2 times 2x plus 5. Now we got a nice little linear equation to solve. So moral of the story there is, watch for common factors within fractions themselves when you're solving an equation. And if they cancel, life is beautiful because that's less work. Oh, this one's interesting. Look what happens here. 4 x's are going to cancel out and you get this weird statement, negative 13 equals 10. I don't think so. So this is a bogus statement. This is inconsistent. which means there's actually no solution. So thank goodness we didn't waste our life doing that quadratic. We would have found out from our quadratic work that the only answer we got actually had to be crossed off. Like you would have done a whole bunch of work and got x equals 1/3 and then went, oh, it's extraneous. So with a lot less work, we figured out that there was no solution to that equation. All right, that concludes our lesson on solving rational equations. The final lesson in this unit is an application of solving rational equations where we combine work. And we see how long it'll take someone to finish a job if they join up with a partner. So pretty cool.